Next important topic is rotation of the plane mirror and its effect on the reflected ray. If the plane mirror is rotated by an angle of theta about an axis in the plane of mirror, then reflected ray and so image rotates by angle of 2 theta in the same sense. That means if mirror is rotated clockwise, then the reflected ray also get rotated clockwise by an angle of 2 theta. And if mirror is rotated anti-clockwise, then the reflected ray and so image will be rotated by angle of 2 theta in anti-clockwise. For example, suppose this is the plane mirror and normal is n, a ray incident at normal point at angle of incidence I, then reflected ray is r, which is having the angle of reflection r, and this angle I equal to angle r. Now the mirror is rotated by an angle of theta in clockwise direction. Suppose this is the mirror new position after rotating an angle of theta. So this normal get also rotated by an angle of theta from its previous position. So angle of incidence in new case will be angle I plus theta. This is the angle I dash. So angle R dash will be also equal to angle I dash, that is angle I plus theta. Therefore, the new reflected ray is shown here. And now, if we consider the total angle, this is the incident ray I and this ray is the reflected ray. So angle between incident ray and reflected ray is 2i. While the angle of incident ray and the new reflected ray R dash will be I plus theta and I plus theta, that is 2i plus theta. Therefore, we can say that the rotation of the reflected ray is clockwise because mirror is rotated clockwise, and this angle of rotation of the reflected ray will be 2 theta, which we have mentioned here. Similarly, if the plane mirror is rotated by an angle of theta about an axis perpendicular to the plane of the mirror, that means suppose this is the mirror and this is the point and a normal is perpendicular to the plane of the mirror, then on rotating the mirror there will be no change in the reflected ray, so image will not rotate. Let's take a problem. A ray of light traveling at an angle of 20 degree below the horizontal. So as per this question, suppose horizontal is shown and a ray is traveling at an angle of 20 degree with the horizontal. At what angle with horizontal must a plane mirror be placed in its path so that it becomes vertically upward after the reflection? Suppose this ray strikes on the horizontal mirror. Then angle of incidence, if we calculate, it will become 70 degree because alternate angle are 20 degree between the two horizontal lines. Therefore, the angle between the incident ray and the normal will be 70 degree. And as per the law of reflection, the reflected ray will also make 70 degree with the normal. Now, we required as per question that the reflected ray becomes vertically upward. That means it should be vertical. That means we want the reflected ray in the normal direction. This is the new position of the reflected ray. For that, the ray should be rotated anti-clockwise by an angle of 70 degree. And this angle of the reflected ray will be equal to 2 theta if angle of rotation of the mirror is theta. Because ray is rotated anti-clockwise, so mirror should also rotated anti-clockwise. So theta will be equal to 70 degree by 2, that is equal to 35 degree. So we can say that the angle which with the horizontal a plane mirror should made 35 degree to make the reflected ray vertically upward after the reflection. Another problem is Suppose two plane mirrors are inclined at an angle of 30 degree. A ray incident at 45 degree as shown in the figure. Find the angle of deviation for the combination of the mirrors. If we draw the figures, they are the two mirrors which are inclined at an angle of 30 degree. And one of the ray strike at one of the mirror at an angle of 45 degree. So as per law of reflection, this ray reflected at an angle of 45 degree. This is the first reflected ray. This is incident ray. And angle of reflection will also equal to 45 degree. To find the angle of deviation, we further proceed the incident ray, and the angle of deviation will be incident ray to reflected ray in clockwise direction, and it will be equal to, say, delta 1. This will be pi minus 2 alpha 1 and pi minus 2 into, because angle of incidence in first mirror case is 45 degree given the problem, so it is pi minus 90 degree, and pi is 180, so delta 1 is 90 degree, and it is in clockwise direction. Now at the second surface, we draw a perpendicular on the mirror at the point of incidence of the reflected ray. The angle is 30 degree and another angle of the triangle is 45 degree. So remaining angle is 105 degree. And normal makes 90 degree. So remaining angle of incidence at the second surface, that is I dash, will be equal to 105 minus 90, that is equal to 10 degree. And because I dash equal to R dash, so I dash equal to R dash equal to, say, alpha 2, this will be equal to 15 degree. And angle of deviation in second case, that is second mirror, will be equal to pi minus 2 alpha 2, where alpha 2 is the angle of incidence for the second case. It is pi minus 2 into 15 degree, that is equal to 180 degree minus 30 degree, and it is equal to 150 degree. This is the incident ray and this is reflected ray, second reflected ray from the second mirror. So incident ray and reflected ray have the direction anti-clockwise. So 150 degree is anti-clockwise. So net deviation is delta 2 minus delta 1, because these are in opposite sense, one is clockwise, one is anti-clockwise. So to find the net deviation, we have to take the difference, and it will be equal to 150 degree minus 90 degree, that is equal to 60 degree deviation in the anti-clockwise direction. This is the answer. Next point is images formed by the plane mirrors. If the two plane mirrors are parallel, then number of images will be infinite. And if two plane mirrors are inclined at an angle of theta, then number of images will be equal to n, that will be equal to 360 degree by theta minus 1. Let's take an example of the two plane mirrors and an object. This is the mirror number 1, this is the mirror number 2, and in between there is an object. So there will be infinite images. Suppose distance of the object from the mirror 1 is y and from mirror 2 is x. So first image formed, suppose, is I1 by the mirror M2. So this will be at a distance of x. Similarly, the image formed by the M1 of the object, it will be, say, I2, and distance of the image will be also y. Now this I2 will act as the object for the mirror M2. Therefore, distance of the I2 from the mirror is y plus x, that is equal to x plus 2y. So third image will be formed from the M2 at the distance of x plus 2y. Similarly, I1 will act as the image object for the mirror M1. Therefore, the distance between the mirror and the image I1 is y plus 2x. So, I4 will be formed behind the mirror M1. This is the I4 and distance will be y plus 2x. And in this way, there will be infinite image will be formed.